Basically, you can get it if you go look for on your iPhone or Android device. If you look for before you fly the letter B, the number 4, and then U, FLY. Just go look for that app on the App Store, and you'll find it. It's a great app that will allow you to see what kind of airspace you're standing in. And I believe you can also put in a certain address for a destination that you want to go to and find out what that airspace status is as well. I'm sorry, the lady who asked me to turn down the volume, is this better for you, ma'am? Okay, thank you. Okay, so let's see, NOTAMs, notices to airmen. This is something that happens normally when a pilot files a flight plan. Some of the things you'll see there is, for instance, if you go, normally they're associated with airports. So if I were able to click on this NOTAM link, it would take me to a website where I could put in VNY, for instance, for Van Nuys Airport. And then it would show me the NOTAMs associated with Van Nuys Airport. Notice to airmen. And I apologize to the women. This is a term the FAA uses, airman, okay? Not my fault, okay? But it's so, the notice to airmen associated with, if you go to VNY, what you might find is something about this runway is open. There's maybe a problem with the lighting on a certain runway, that type of thing. That's the kind of information you'll find there, okay? Also, I should talk about TFRs. Can anybody read this TFR? That's the stuff in the box at the bottom. Well, that's a NOTAM, isn't it? That's actually a NOTAM, I apologize. In the box at the bottom. What are they telling you here? Well, they're telling you the airport is KSRQ, right? I'm not sure what airport that is, but the airport is SRQ. And the thing, even if you don't know how to read the whole thing, what you can get out of it is they're going to be cutting grass daily around the runways at these times. Okay, so just that's the kind of information you might get in a NOTAM. Yes, weather. Okay, let's talk about weather. Let me go, I'm going the wrong way here. Get back here. Okay. So the good news is we're flying small unmanned aircraft. Do we have to be worried about the weather? Thank you. Oh yeah, from over here, right? Maybe not as much as a manned pilot because I'm not flying way up in the clouds at 10,000 feet and I'm not flying long distances and going through multiple weather systems. However, even if I'm standing on one place and flying below 400 feet, weather is a very dynamic thing and it could be moving into my area very quickly. Witness what's going on in Texas right now in the Gulf Coast. So the bad news is you can have pressure changes, barometric pressure changes. You can have winds, surface heating, which results in kind of thermal currents coming off the surface and causing this little bit of turbulence going on close to the surface. And obviously visibility and precipitation. So let's talk about visibility. This is obviously partly for you so that you can see obstructions, but it's also for manned aircraft so they can see you. And the FAA regulations say that you've got to have 3 miles visibility. There's this thing called ADS-B, which stands for Automatic Dependent Surveillance Broadcast. You can have a receiver, you can have an ADS-B receiver, or you can have a transmitter and receiver. If you're a commercial aircraft like an American Airlines, you have an ADS-B transmitter on board, and you are transmitting at all times information about your altitude, your speed of flight, your location, specifically by GPS coordinates, so on and so forth. And that information is coming down to receivers, stations that are on the ground, and it's consolidated and sent back to a site where the FAA can use it on their radar screens. I think it's January 2020, am I right? Yeah, January 1, 2020, all general aviation aircraft will have to have an ADS-B transmitter installed. So it's not about just being able to receive it and look, but as a general aviation pilot, you're going to have ADS-B installed. I suspect it's not going to be that long before that's going to be a requirement something like that for drones as well, although we don't know exactly what's coming down the pike. But it's got to happen because somehow we've got to figure out how to control this airspace with Amazon drones running around delivering stuff, like the lapel microphone that I ordered on Thursday and was supposed to come yesterday, but it didn't, so that's why I'm holding this mic. Let's see. Okay, we talked about minimum visibility earlier. Again, it's 3 feet visibility, and it's also 500 feet below clouds, below a cloud cover. So one of the things you do, excuse me, if you're going to go flying, let's say I'm going to fly somewhere here in the San Fernando Valley. Maybe it's within 10 miles or so of Van Nuys Airport. I'll go look at the METAR, which is the weather report for Van Nuys Airport, in order to look at the cloud ceiling. Where is it right now? If that cloud ceiling is below 900 feet, I've got an issue because I can't fly closer than 500 feet to a cloud ceiling, right? Even though I may have 5 miles visibility, but if I've got a 700-foot cloud ceiling, what's my maximum altitude? 300 feet, right? Because I can't fly, 200 feet. Thank you. I can't fly closer than 500 feet to that cloud. So it's a consideration. It's something that you have to look at, especially this time of year here in Los Angeles when we have the marine layer often in the morning, more so perhaps in May and June than now, but we've still had some of that going on. So something to think about. Oh, I want to talk also, before we get away from this, I want to talk about, let's see, did we talk about this? No, we're about to talk about it, sorry. Okay, here we go, wind. So, what about wind? Bigger machines can handle heavier winds, generally speaking. So if you're flying a little drone, I mean, look at what Bill has over here on the Blue Skies table. It's a Phantom 4, right? And it's not that big. It's subject to wind gusts. If you get winds over about 10 or 12 miles an hour, you're going to have some issues with it. Okay, so the bigger the machine, the better the wind in terms of how it will handle the wind. If you want to capture silky smooth footage at 10 knots, you're going to need a pretty big rig and a pretty good gimbal on that rig, because you're not going to get silky smooth footage at 10 or 12 knots with the Phantom. It's just because it's going to be juggling to hold its space too much. So wind is a fickle thing, which may actually result not just in unstable footage, but also uncontrollability. Examples might be strong wind currents, or if you're flying close to the ground, wind can change very quickly in very different ways. Excuse me. If you're flying close to a building, let's say, hi Claudia. This is Claudia with Rotor FX. If you're flying close to a building, and let's say I'm the building, okay, and I'm flying out here in front of the building, and I'm facing into the wind, okay, what's going to happen as the wind hits the building? It's going to hit the building and it's going to go like this, right? And that's not a good thing if you're flying close to the building, because you're going to get unpredictable air currents going on, especially if it's a hot day. Then you got the thermal issue that kind of mixes in with this wind that's mixing around against the building. And the same thing holds true not just with buildings, but also with hills and mountains and any kind of obstruction that can block the wind. Not just will block the wind, but it'll mix it up. Another thing to consider, again, if I'm the building, excuse me, and let's say now I'm the building, the wind's coming from this direction, and I'm taking off from back here on the non-wind, right? The building is blocking the wind, okay? If this is the edge of the building, what's going to happen when I fly? If this is the edge of the building, okay, and I'm taking off behind me, what's going to happen if I fly from here to here? I'm going to hit a wind shadow, right? The wind is going to come, and I didn't know it was coming because I wasn't aware of it. I was behind the building. So you got to be aware of stuff like this, and you got to watch for it, and you have to anticipate it. Yes, density altitude. How dense is it? Okay, so there's this thing called standard pressure and temperature. Standard barometric pressure is 29.92 inches of mercury. Hg stands for mercury. And standard temperature is 15 degrees Celsius, which translates to 59 degrees Fahrenheit. So, what you're going to find is all of your drone performance measurements will be made at standard barometric pressure and standard altitude. Meaning that if I buy a DJI Phantom 4 or rent one from Blue Skies, okay, and I go fly it and I look at the specs and it says it's got 22 minutes of duration or flight time, right? I think, great, I can fly for 22 minutes. Well, guess what? That would be great if you were flying at sea level. What if you're flying at 4,000 feet? The air is less dense. It's called density altitude, right? So what's going to happen in less dense air? I'm sorry, I can't hear you. It requires more power to fly. Not just more power to fly, but ultimately, if you get into a situation where you have a heavy payload that's marginal when you first lift off at sea level, you get to 4,000 feet, you've got that same payload, you may not even be able to get off the ground. Or if you can get off the ground, you don't have any performance margin, meaning that you need, when you get off the ground to fly a payload, you need a performance margin that gives you what you need to accelerate in order to control the aircraft, to rise or fall or to move forward. All of that requires extra power. And if you're carrying a marginal payload at a marginal density altitude, and the props are having a tough time chopping that air enough to keep you in the air, you've got a problem. So a density, yeah, is density altitude a thing for unmanned aircraft? Yeah, it is. Especially when you get up to the higher altitudes or on the hot days. I mean, we've all heard how about if it gets like, sometimes it gets in Phoenix or in the Arizona desert to above 110, and they say some airplanes can't fly. That's because they can't get enough, the air is not dense enough to give them the lift that they need to get off the ground. And you have the same problem with a propeller, because what is a propeller really? It's just a little wing that spins. Instead of a fixed wing, you got on the Phantom, you've got 4 little wings that spin, right? They're cutting the air, and they're giving you that lift. Does that make sense? Okay. Whew, we got through density altitude. Wow. Loading and performance. This is fun. We talked about that. We started to nibble around the edges of that when we were just talking about payload, okay? And it's not just payload, but it's also the performance of that payload. So what happens on a small drone with a fixed camera? Can I borrow your Phantom for a second? Thanks, Bill. So here's a Phantom 4. Professional, yeah? That's Phantom 4 Pro. It's a great little rig. It's a nice little camera on the bottom there. It's a great design because what they've done is they've taken the optical system and sensor out of a real camera, and they've repackaged it and repurposed it for use on a drone. It's a great package because it's light, it's easy to control. The gimbal requirements for a small package like this are a lot less than the gimbal requirements would be for a big camera like what Don is shooting with, right? Don, bring one of your cameras up here as long as you're headed this way. And show, I mean, if you put one of Don's cameras on a drone, do you think it's going to be more difficult to control? Yeah? Okay, and not just difficult to control, but look at this thing. Look at the length of the lens, okay? Do you think you might have some balance issues relative to the center of gravity on the drone? And we'll talk about that in a minute. Oh, I got to give this back. Thanks, Don. Thank you, sir. Guess what? My mic just came. That was my wife that dropped off this mic. I'll put it on at lunch. Okay, where are we? Loading and performance. Oh, moving cameras also. What if, I'm going to use your camera as an example, Don. Thank you. I know I'm making you crazy now. What if this lens, now, I'm not sure. May I zoom this? Yeah? Okay, so this is internal. Right, so this is a professional lens, meaning that if I zoom it, the zoom happens internal to the lens. The lens doesn't get longer because the optics are all moving inside the lens. But on some less expensive lenses, what happens is when you twist the zoom ring on a telephoto lens, the lens actually extends. And what does that do to, if it's hanging on a drone and it's perfectly balanced at this point, but if I extend the lens out here, what does that do to the center of gravity? It throws it off. There's going to be more weight on the front of the drone, right? So that's a problem because now the drone is going to exert more power on the front two propellers in order to keep itself level. So it's going to reduce your duration time. Ultimately, it could affect your ability to control it, again, if your payload is marginal in terms of the amount of weight that you're carrying. Make sense? Thank you. Okay, load factor. We really talked about that for the most part. Could you have a stall situation with a quadcopter? Absolutely. Again, we talked about this. The propeller is nothing more than a spinning wing, and if it's got too much load, and if the winds come, and let's say you got a wind coming, a heavy wind coming from that direction, now you're trying to, it's leaning in order to keep itself stationary, which these drones do based on GPS coordinates. It's leaning into the wind, so it's exerting more force there. Now, if you've got a marginal payload, you're spending all your time trying to stay level. You may lose altitude while you try to stay level, and ultimately you could crash, right? So this whole loading and performance and balance thing, it's a real thing for drones and aerodynamics. Performance, good sources of performance information are the manufacturer's handbook. You'll find the specs in the handbook, obviously, the user's guide, information about the duration and flight time and things like that. You should be aware of those specifications. The one thing to remember also is, even though there are specifications out there, what if you get out there with that Phantom 4 and something happens and it's not balanced correctly or something like that? Who's responsible if that drone crashes? Is DJI responsible? No, you're the pilot in command. You're responsible. You own this whole situation, baby. From start to finish, from ground to altitude. You own the whole thing. If that DJI drone crashes because of a firmware problem, it's not DJI's problem in terms of liability, it's your problem. Proficiency. Let's talk about stick time, right? What's this thing called proficiency? What do we mean now? For some of my pilots, when I say proficiency, what does that mean to you? Skill and ability. Perfect. Thank you. Skill and ability. What does that mean? It's experience, right? How much experience do you have with that particular aircraft? And on a UAV like the Inspire 2 here or the Phantom 4, what they translates to is stick time. And the key to this is just get out there and get your stick time. People often ask me, are they difficult to fly? Well, no. I mean, I could set it up and have it flying in 5 minutes, and there's actually a button you can press on the screen of the DJI Go application to have it take off and hover at 4 feet. That's a no-brainer, right? Yeah, until you have to actually fly it, okay? And the key is, when you first start flying these things, as many of you know if you're flying them now, right, It's great when it's nose out, because I've got left is left and right is right, and forward and backward are the same. But what happens if it's facing me? Everything's reversed. Everything. Okay? And what happens if it's going this way? Right? Or this way? So you get the idea. The key to this thing is getting enough stick time to where responding to a situation becomes intuitive. Meaning that if I'm flying, and guess what, I'm getting too close to a tree, I'm going this way, what do? I'm going to hit backup, right? Which may not be intuitive until you've got enough stick time to know to hit go backwards instead of go forward, right? So my recommendation to you would be go out and get 20 or 30 hours of stick time before you ever even think about shooting commercially. And make sure that what the stick time you get is with the aircraft you're going to fly. Because all of them have different, they're similar, especially the DJI rigs, they're very similar. Because they have the same basic control system. But get experience on the rig you're going to fly and get a lot of it before you go out and start flying. I think I really blew by that. Okay, so aircraft, understanding failure modes, abnormal situations, flyaways, loss of GPS. What could an abnormal situation be? Problem with a firmware update, perhaps? A motor failure? Prop breaking or spinning off or something like that? Not charging the batteries, running out of power too soon and the drone falls out of the air, right? How about flyaways? What does that mean? You get up, you get in the air, you get, I don't know, what happens? You get on you accidentally get on the other side of a building and the signal can't get through the building to the aircraft. Well, you've got two problems there. The first is you should never have gotten on the other side of that building because you're not supposed to fly beyond line of sight, right? The second problem is now you've lost your control link. What's going to happen if that drone is on the other side of the building and you lose your control link? Well, one of two things is going to happen, okay? Depending on whether or not you programmed it properly for the fail-safe mode. And I think pretty much all drones these days have what's called a fail-safe mode or return-to-home function, right? And what that means is before you even get off the ground, you program the drone to say, if a lost link situation occurs, here's what I want you to do. I want you to stop. Whatever you're doing, stop. Hover in place. Fly up to a certain altitude that I specify because I want to get over buildings and trees, and then fly back to the point of launch. And from that point at the specified altitude, hover and then descend and land all on your own, okay? And that's the way you program the return to home function on most of these drones. If you haven't properly programmed that, let's say you didn't set the altitude right and you get on the other side of that building and you lose your link, what's going to happen when it starts to return to home? It doesn't rise high enough. It's going to fly into the building, right? Or trees or whatever. Now, some of the newer ones, even like this, the Phantom 4 and the Inspire 2 now, they have obstacle avoidance systems on them. So they are smart enough that if they start to fly toward a building, they're going to stop. And in fact, I think it's even with the Phantom 4, they have a system in there that says, I will follow the same path back as I followed out. In other words, instead of let's do it this way. So I launch from here. Okay, let's say this. This is me. This is the building. This is where I fly to. And now I'm on the other side of the building and I lose the link. The way I got from here to here is I flew around the building, okay? If you didn't have this function that says go the same route that you came from, but rather the old style return to home function that says draw a straight line from where you are to where you came from, you're bumping right into the building. But if you have the smarts in the system to say, if a failure of the link occurs and I have to implement my return to home function, I'm going to follow the same path that I followed to get out here. I'm going to go around all those same obstacles, right? So there's a lot of intelligence being designed into these systems for that type of lost link failure. But you have to use it properly. So again, it's about experience. Read that manual. Don't do the macho thing and says, I can go fly it. Read the manual and learn how to use it. Yes, sir. Lost link means lost signal, yes, sir. That means I've lost the control link or the control signal between my control station and the aircraft. Okay, enough about that. Oh, loss of GPS. We got to talk about loss of GPS for a minute. So we talked about the functionality on most of these drones, especially that I hate to use DJI as a reference, but they are really the gorilla in the room in terms of the volume of their stuff that's out there. So for the systems like you see over here, they run on GPS, Global Positioning System. That's how they hold their place in space. Okay, so they actually talk to a minimum, what's known as a good GPS lock is a minimum of 7 GPS satellites that aircraft is talking to. I've had mine because you can see on the screen the number of the number of satellites that your aircraft is talking to as far as GPS satellites. You can see the number of them on the application. I've had as many as 18 satellites locked for my GPS lock. The key is the GPS lock, right? If that GPS fails, what happens? Your airplane is going to lose stability, right? It's not going to be able to hold its place in space because it doesn't know where that is. It doesn't have the satellites to talk to. So my point is this. GPS is a great thing because it helps you. If something happens, let's say and you're out there flying and you don't have quite enough stick time and something happened, what do? Let go of the sticks. It'll stop like that. It'll hold its place in space if it's got the GPS coordinates locked and loaded, right? But if you have a GPS failure or a marginal GPS lock, what happens? It may drift in a marginal situation. In a total loss of GPS lock, it's not just going to drift. You are in control, baby. And that means if I want to hover here and wind is coming from over here, right? What's going to happen? It's going to blow that way. It's going to drift with the wind because the GPS lock is not going to hold it in place. So my point is not just stick time with GPS on. Turn it off. Learn to fly that rig totally manually, 100%. Get totally comfortable flying it manually. Don't use GPS lock as a crutch. Okay? State of mind. Boy, does that sound mushy or what? Let me ask my pilots in the room. Is this a thing? Is this a real thing, state of mind? It really is. Sir, did you have a comment? Yeah, so I'm going to talk about state of mind. I'm going to talk about what that is. Exactly. You're going to get more information than you thought you wanted to know, actually. State of mind, okay? This is about how there are a lot of things that go into this. It could be state of mind like, how do you feel today? Are you in a good mood? Are you in a bad mood? Did your wife just call you and tell you she wants a divorce? Did your mother just die? Right? Did you have somebody who was affected by the hurricane in the Gulf Coast? State of mind. You're preoccupied with something. But it's not just that. It's not just a preoccupation. The FAA has defined 5 different states of mind, or they call them hazardous attitudes. So anti-authority, don't tell me what to do, right? I know what to do, don't bother me. Leave me alone, I'm flying. Or how about impulsivity? You're on a set, and the director of photography says, you need to get this shot, right? Your impulse is going to be, okay, I got to go get this shot. The pressure's on, right? Do it now. Hey, wait a minute. Are you going to throw safety aside and go for that shot? Or are you going to stop and think about what you really should be doing here? Impulsivity. How about invulnerability? This is the macho thing, or well, it's actually two different things. Invulnerability. It's not going to happen to me. It only happens to other people. Only other people fly into, drop a $50,000 RE camera or $100,000 camera, right? It's not going to happen to me. Machoism. I'm going to show these guys. I can do it. Damn it. I'll show them. You got no idea what I can do. I'll show you. How about resignation? Oh, crap, this thing's not working right. What's the use? I should just give up. No. There's a way out of every situation. Stop and think about it and figure it out. Don't just give up. So these are, all five of these are legitimate, right? Am I right, pilots? These are what you learn. In fact, you have to learn this for your knowledge test for Part 107. So learn these things. Mission mindset. This is, so I talked about this briefly with one of the hazardous hazardous attitudes. Mission mindset. It's not a mission. You're not out to shoot somebody or something. It's a flight. You got to pay attention to what you're doing. You're flying the aircraft. And very few things justify taking the risks that you might feel that you want to take with people and safety and everything else that could happen if this thing goes south on you. So just be aware that mission mindset, this kind of mental state that says, oh man, I got to go do this. Because it could be just one small thing. Okay, the wind's blowing at 12 knots, and it's kind of on the edge, it's marginal. Well, okay, I'll fly it. But then, you know what, I'm at a 4,000 foot density altitude, and the wind's blowing at 12 knots. But this guy really wants me to get this shot, right? Should I fly this? So it's that kind of thing, right? You're going to take those risks. You got to know where to draw the line. The FAA calls them personal minimums, right? Where do you stop? Where do you turn to the director of photography or the client who's asking you to get the shot and say, I'm sorry, I can't do this. The conditions have changed too much. It's not safe. You got to do this. You're the pilot in command. If something happens, your license is on the line. So what are any other examples of the kind of things that could lead to a poor mindset? To something that we haven't touched on? Sleep? Yeah. Fatigue, right? Fatigue. Coffee. Too much? Not enough? It goes both ways, right? So yeah, there's a lot of things. I'm sorry, sir, did you have a comment? Dehydration, thank you very much. I actually have that on one of my slides, but thank you. Dehydration is a real thing. If you get dehydrated, it's not just going to affect you in terms of how you feel physically. It can affect your thinking, your state of mind. It's a very real thing. Okay, let's talk about decision making. The FAA has this thing called ADM, or aeronautical decision making. This is it's actually a protocol of when you get into a situation, how do you think? You discipline yourself on how you think yourself through a situation. And it was designed for manned aircraft pilots. It was, I want to say it was United Airlines. Does anybody know? I think it was United that first came up with this years ago. And they wrote it up as an internal training thing for their pilots. And ultimately it's evolved now into an FAA standard called aeronautical decision making. But it's a specific protocol on how you think your way through a particular situation, instead of panicking, right? Instead of saying, holy crap, what do I do now? Think, okay, well, what's going on here? I got this factor and this factor and this factor that are outside influencers. And I've got this crew. If I'm the captain, I've got my first, my co-captain. And I've got these hardware facilities at my command. How can I put all those together and make the right decision? So it's a disciplined way of thinking about how you do this. Risk management is another thing that goes hand in hand with ADM. It's things like situational awareness, problem recognition, good judgment. And then there's this thing called crew resource management, which again, it kind of all is intertwined with ADM in terms of how do I manage the hardware resources and the human resources and the information resources that I have at hand in order to navigate my way through this situation and come out alive, basically. Come out without crashing. And some of the things that apply to crew resource management, this is not just about manned aviation, folks. It really applies to unmanned as well. Things like delegation of tasks, management of crew, recognizing hazardous attitudes, either in yourself or one of your crew, and addressing them properly and quickly. Establishing effective crew communication procedures. If I'm working with a visual observer when I'm flying, I want to have a specific set of protocol. I don't want, if something's up there and the plane's flying up there and I'm looking down here to see the altitude or what's framed up in the camera, and my visual observer's over here, if something's happening, I want a standard set of phraseology that they're going to use to tell me what's going on. I don't want to have any communication problems. I can't afford to have communication problems. Time doesn't permit it. Another thing is being able to field questions and concerns from your crew, right? Be open to questions and concerns from your crew, because sometimes it can give you information you don't have when you're in a critical decision-making situation. Don't just blow it off. Now, the flip side of that is it could be really stupid and then you have to blow it off, but that's, you have to filter that. Don't just totally blow it off. And then there's safety. One of the big issues with lithium-ion batteries, or they're actually properly called LiPo, they're lithium-ion polymer batteries, is the chemistry that's commonly used in drones these days. And it's a somewhat volatile chemistry. It's kind of a blessing and a curse. The blessing is it's the lightest energy density you can get today, meaning it's the lightest amount of, in terms of the amount of energy that's in the battery versus the weight characteristics, it's the best performing for battery chemistry that's broadly available today. The downside is it can be somewhat volatile, especially if your drone crashes, the battery falls off, the packaging on the battery gets punctured, something like that happens. What do you do with that battery? Dispose of it. Thank you. Actually, properly dispose of it. And there's a way to properly dispose of a battery like that. It's put it in salt water. Sounds crazy, but I'm sorry, it broke up. Put it in salt water. It sounds crazy, but that's what you do with these batteries. And let them discharge over a period of several days. They'll discharge and then properly dispose of it. Just don't throw it in the trash. Take it. What I do with mine is I take them to Home Depot. Because what you'll find at the customer service counter or near the customer service counter at Home Depot, there's this bin, and it's designed for people to throw away the lithium batteries that come with power tools. But it's a legitimate place to throw away a battery, right? And it'll be properly dealt with. Don't just throw it in the trash, because you don't want this stuff ending up in the landfills, right? Okay, so let's see. Anything else on batteries? Oh yeah, other signs of damage. Who can tell me what another sign or another thing to be aware of with LiPo batteries? Swelling. Thank you. That's exactly what I was looking for. Swelling, right? If you get a swollen package, that tells you that this battery it's got one of three things going on. Either it's got an internal short, or it was improperly overcharged, or improperly and discharged too far to a low voltage. Okay? So what are those voltages, you might ask? This gets technical. You might want to write this down. If you don't write it down, you can find it online. Just Google LiPo batteries, okay? But there are 4 recommended voltage characteristics that you should be aware of when you're working with LiPo batteries. First of all, never overcharge beyond 4.2 volts per cell. These are multiple cell batteries. They can have anywhere from a single cell up to as many as 12 or perhaps even more, right? In some of these huge batteries that they use on these great big rigs. 6-cell batteries are not uncommon. 6-cell battery with 16,000, 20,000 milliamp hours. That's a battery, it's probably about as big as this or close to it, right? There's a lot of power in that battery, and a lot of things can go wrong if you don't treat it properly. Well, one of the things, too, that I wanted to talk about in terms of properly dealing with batteries before I go there. Hang on just one second, sir. Jewelry. When I fly, I don't wear any jewelry except if I wear a watch, it has a rubber band. Why is that? Because I don't want to short something out. I read a story a few years ago about a RC helicopter pilot who shorted a battery with his wedding ring, and it damn near took his finger off. There's that much power in these batteries, and it created a heck of an explosion. I'm sorry, sir, you had a comment or a question? Milliamp hours and what? It gets beyond the scope of this presentation, and unfortunately I don't have time to address it technically, but the gentleman was asking about milliamp hours and what that equates to. It's basically a measure of the amount of power that is in the battery. So a battery with 20,000 milliamp hours will fly a lot longer theoretically than a battery with 10,000 milliamp hours given the same load. Okay. Now there are other trade-offs that you have to when you get into designing these aircraft, because what happens is you got weight trade-offs too. So you won't, if you go from take the same exact aircraft, you go from a 10,000 milliamp battery to a 20,000 milliamp battery, are you going to get the same exact flight time? No, because the 20,000 milliamp hour battery weighs more. So that's going to reduce your flight time because of the added weight from the battery. So there's a lot of, this is somewhat complex when you get into that. But anyway, so I want to talk briefly about these other voltages. Never overcharge beyond 4.2 volts per cell. Never discharge beyond any lower than 3 volts per cell, 3.0 volts. I use 3.2, but the technical guideline is 3.0. And then there are 2 other voltage levels that you should be aware of. Or actually 2 other things that you should be aware of relative to a voltage level called the storage level. These batteries are happiest when they're stored at 3.72 volts per cell. What does that mean? Hang on. What that means is, if I have a battery, I've fully charged it to 4.2 volts per cell, but I don't fly for a couple of weeks. I shouldn't let that battery sit with a full charge in it for more than about 7 to 10 days. After that, I should discharge the battery to a storage voltage of 3.0 volts per cell. Okay? And the reason for that is because the way the battery chemistry is designed, they don't like to be fully charged or fully discharged for long periods of time. They like to be stored at a voltage that's about halfway in between the full charge and fully discharged level. So if you get into a storage situation, you want to discharge your batteries to 3.7 volts. How do you do that? Well, if you're flying DJI, they have what they call intelligent batteries. They will self-discharge after 10 days is the default, or you can specify if you want it to discharge after a few days, 2 or 3 days, you can change that parameter. Okay? If you're not flying DJI, you still need to take your batteries to a safe storage level if you're going to be storing them for more than about a week. And most of your battery chargers that you buy these days for LiPo batteries will have a function that will discharge the battery automatically to 3.7 volts. It just bleeds off that voltage. It takes a while in most cases, but you just set it and it automatically bleeds off the voltage. One other thing, and then I'll get to your question. One other thing about storage. If you're going to store it for more than about 3 months, you need to recharge it back up to that storage level, because in storage, that storage voltage of 3.7 will slowly taper off. And you want to, again, recharge it so that it's kept at 3.7 volts. I'm sorry, folks, a lot of technical stuff about batteries, but all of this will help you keep your batteries safe, avoid fires and explosions, and give your batteries the longest possible life. You had a question, sir. So the question was, what do the drones do about managing the batteries? Do they have low voltage cutoffs? And the answer is it depends on the controller you have in the drone. Most of them do. At a minimum, if the drone doesn't have a low voltage cutoff, most of the systems today will give you telemetry, which is data that comes back, is transmitted from the aircraft back to the ground control station. And that telemetry will typically include the voltage level, and you monitor it yourself, and you just shut down when you get to about 3. I usually use 3.4 volts per cell as the level when I'm saying, okay, it's time to return to home, if it's not done automatically for me, depending on the system. Make sense? Okay, sorry, that's a lot of stuff about batteries, but it's very important. For anybody who's an old RC pilot, there's also this thing called fuel, aka gasoline. What's the thing about gasoline? Well, I would submit that it's actually a lot more stable than lithium polymer batteries, lithium ion polymer or LiPo batteries, right? Generally speaking. The thing about gasoline is, if I had a puddle of gas on the ground here and I threw a lit cigarette in it, the liquid gasoline would put out the cigarette before it caught fire. Isn't that interesting? But if I'm in this room and I've got a puddle of gas and I hold a match above that puddle of gas, the fumes will ignite instantaneously. And then that puddle of gas is on fire. So the point is, you got to watch out for the fumes as much as you do have to watch out for the gasoline itself. So store it properly and use it properly. You got to be careful also. Some of the gasoline containers that you use can have spouts that'll spill gasoline all over the place, so just be careful with it.